Okay, let's start then. So today we are going to discuss firewall and route table. Okay, so if I go to the virtual network site, right, we are yet to see the route table in this. Rest all things we have covered. Okay, and firewall is something which we are going to see. Okay, so to explain this concept, okay, like what I have done is, so this is how our setup looks like. Probably let me just do a new diagram so that it will be easy. um, we have three different networks. Okay, um, let me just draw this. The first one is like, if you all remember, like we discussed about hub and spoke architecture, right? So I have a VNet called hub VNet. Okay, let me just move this. Then I have a VNet called spoke VNet, and I have another spoke VNet called spoke 2. Okay, spoke 2 VNet. Now, in hub VNet, we have something called I'll say Azure Bastion, okay, which is deployed. And in Spoke VNet, I have again, like if I have to talk about subnet, right? We have something like Spoke 2, Spoke 1 subnet, and here also we have Spoke 2 subnet. Okay, like this, I have a subnet, and then I have a VM, okay, which is VM1, or it's actually spoke one VM1. I have named it like this. Similarly, if I have to draw here also we have a VM. This time I have chosen Windows VM. It spoke to VM2. Okay, this is how the setup is right now. And additionally, okay, today we are going to learn something about Azure Firewall, which in our case, it will be sitting in the hub subnet. Okay, I have also firewall. Since this Bastion and firewall is something which will take good amount of time, right? So I have deployed them before the start of the session itself. Okay, just to save some time. But this is how the setup looks like. Okay, what I have done is there is a peering which is configured between these two network. Okay, there is a peering which is done, and similarly, like there is a peering which is done. Wait, if I can, I don't know. Okay, fine, never mind. So there is a peering which is also done to this network. Okay, there is a peering available here as well. I'll show you all these things as well, but just remember there is a pairing. So this is the normal hub and spoke architecture which we discussed. Okay, so one will act as hub. Any traffic which goes out will go via the hub. Okay, there will be spokes which are connected, which means like from the hub you manage all the network related stuff, which is like Bastion, firewall, and all. So this is the setup. And till now, what we know is if I, let's say, there is an users who are connecting, right? Let's say users who try to connect. Okay, Wait, what is this? Maybe let me just say. Okay. They go via, let's say, Azure portal, and you all know, like from Bastion, we can connect. Bastion is going to give the connection to Spoke 1 or Spoke 2, depending on whichever VM we want to connect. And at the same time, if we want to talk to internet, right? So I have left the, I'll just say internet. I think I should have chosen some other color. Okay. Let's say if we want to access internet from this VM, assuming we have left the default outbound rule, Azure is going to give some common pool of IP from which it will talk to internet. Okay. And when I want to talk to internet, that communication will not go via the Bastion public IP. Okay, we all know till this point. So if any server here, if we are trying to access internet, that is not going to go via Bastion IP. So any doubts on this part till now, like whatever we have seen in the last few sessions? Any questions on this? Because we are going to build on top of this, we are going to make changes to few things, the way how it's going to work. So I just wanted to know if any
Yeah,
questions.
Naveen, in the spoke one, we have a public IP.
No public IP in this case.
Okay.
Okay. Any other questions? Okay. So I assume no, but yeah, feel free to stop me. I'll first show you the VNets. Okay. This is the hub VNet, and here I have two different subnets. One is for firewall, another one is for Bastion. So if you remember, like we cannot change the names of these subnets. Okay, if I choose Bastion, this is going to be the standard name. Since I already have, I'm getting this error, but this is going to be the standard name. Similarly for firewall, this is the standard name. Okay, we cannot change this name, and I have already created it. But just wanted to show you how the interface looks like, right? I'll quickly show that. Probably before even I show firewall, I'll show you the other setups, right? Now, if I move to spoke one, right? This is the spoke one. I have given like 10.10.0.0/16 as the range, and we just have one subnet, okay, just to keep things simple. And let's click on this. If you see, like I have not disabled the default outbound. Okay, so which means it can talk to internet. Then similarly, if I go to spoke to, I have one subnet in this case. And again here also, like if I have to show you, the access to the internet is available, okay, using the default routes. If you remember, we discussed about the default outbound rules and all. This is in place, okay. This is what our setup is. Now what I have done, from the spoke one, we have Bastion. This is hub Bastion, which was deployed. And there is also the peering, which I missed to show. I'll probably show that. So if I go to the pairings, right? Hub is having a pair to hub to spoke 2 as well. Spoke 1 and spoke 2, we have a pairing. That is what I shown in this diagram. So basically, these two can talk. These two network also can talk. Okay, that is what you see here. And similarly, if I go here, you will see, maybe let me go here. You see, it's like a bidirectional, which you all are aware. So one thing which I wanted to highlight is, okay, if I go to this diagram, right, probably what I will do is, to give you a better picture, right, just to explain one topic, I'll just open Paint again, a different Paint. Let's assume you have something like this, and let's say this is your hub, and let's say this one is your spoke 1 VNet, and similarly, this is your spoke 2 VNet. Okay, now assume there is a pairing between these two networks. Okay, wait. Okay, I'll just keep it one. There is a pairing. Okay, and there is a pairing between these two networks. Now, hub can talk to spoke 1 and spoke 2. Okay, and spoke 2 can talk to hub. Spoke 1 can talk to hub, but there is no pairing between these two networks. Okay, there is no pairing. Okay, which means uh, these two networks cannot talk just because we have a common pairing with hub. Okay, this is what there is a term called transit. Okay, transit connectivity. You cannot send the traffic, let's say, from spoke 2 with this setup. If I want to talk to spoke 1, it cannot go via hub by default. Similarly, Azure, I mean, like from spoke 1, I cannot send a traffic via hub to spoke 2 just because we have a pairing. This is what they call it as a transit connectivity, which is not allowed in Azure. Okay, you can think of like transit, like if you are taking any flights, right? You will have transit flight where you will connect to a different place, and from there you will go, right? Your journey will go something like that. Your network is going to travel. Network packet is going to travel. In this case, Azure will not allow this, and if spoke 1 has to talk to spoke 2 in the setup, this is not possible. But if you have a firewall, okay, now if I go to this setup, right, what firewall can do is firewall will facilitate that. Okay, firewall will have the capability of facilitating that communication. We are going to see that. Yeah, that is one point which I wanted to show you. With peering, this connection is not going to happen until unless you peer these two networks. Okay, now going back to the portal. Okay, I just want to tell because like here we don't have any connection to the spoke to. We're going to see how that communication is going to happen. Okay, now what I will do is I wanted to show you how you can create a firewall. Again, like firewall is kind of a expensive service compared to like other service whatever we have used, right? So if I have to show you Azure firewall pricing, let's quickly check that also. Okay, you see, right? Depending on the type which you choose, maybe I'll change this to South India. That's where I have deployed my resources, and we'll pick INR only. If you see here, right, Azure firewall cost is 160 rupees per deployment per hour. Okay, because this gives you a lot of like features which would be used in case of enterprise level application. If you are more concerned about security and all, there are like whole bunch of great features which are available. Yeah, I just wanted to mention because if in case if you are also practicing, right, just you have to keep an eye on this because this is something which has a good amount of cost per hour basis. Okay. Going back, this is the window which I wanted to show. Let's,
Naveen,
yes.
in the previous class, we have discussed like within the two VNets, we
Hmm.
can use the peering, right?
Correct.
The speak one and spoke one, these two are two VNets, right?
Yeah, both separate network actually.
Okay,
See, if I want to establish a communication through peering, it is possible. I have to do a
okay.
pairing, but I
Hmm.
don't want to do that. Let's say in this case, right? I just have two. Okay, let's take a different scenario. Probably, let's do Control Z. If I have to expand this, right? Just think about a scenario like this. Something like hub here. Okay, and I have multiple networks like this. So in this case, I cannot go and create a peering between these two, like all the machines, right? Like if I want to communicate. So from here,
Correct,
I cannot
correct.
do it, right? If you are dealing with a larger network, this is going to vary. So that is where, like if you are hitting a central point, like some sort of a gateway, which is going to tell where to go, this kind of hub and spoke architecture would be helpful. And if you remember, we also in the other diagram, right, which I have shown, hub and spoke, if you search, Azure also has this network topology, which they have explained. This is the diagram which we picked last class. So
Yep.
here, if you see, there are multiple resource group. I cannot go and create a separate peering for all these things because there is a limited number of peering which you can create as well. Okay, if I think it's around 500 for
Yeah.
peering limits. Right. Yeah, so you see here, right? You can go with up to 500 here. So there is a limit also, and this limit can be increased to 1,000 via Azure Network Manager, all these things. But there is a limit, right? If you are talking about a larger network and all, like you have to be very cautious, like what you're going to pair with what.
Yep, sure.
Okay. Yeah, these are the things which you have to consider. So that's why. Now, going back, so I'll show you, like I'm not going to create because creating firewall itself will take close to 15 minutes. Okay. So that's why I'll show you from the interface and we'll again like go to this in a while. We already have one created, but let me show. Now we have to define the resource group, and I will just use hubrg, and you will just say some name, okay, for the firewall. Then you have to pick the same region where your subnet is virtual network is created, and there are different SKU. Okay, uh, anyone know what is SKU? SKU. What is SKU? This is something which you would see for other places as well. Do you know what it is? Yes. If you're in front of system, you can just do a quick search. Okay, so SKU is nothing but stock keeping unit. Okay, um, which is nothing but it's going to tell what kind of models. Nothing but there are different types of what I can say service which you can take. Basic, standard, premium. That's what they call it as SKU or stock keeping unit. And whatever I have deployed, it is with premium. Okay, it's just the features which gets varied. Basic is very like you get very limited functionality, but standard covers most of the things. Okay, but I have just chosen premium, though we will not be actually testing a lot of things which premium offers because it's not easy to simulate. Okay, but just remember there are different types of options or tiers which you have, models of firewall which Azure is providing. But you can read more about each offerings as a self-study. But just remember this is there. Okay, we are using premium for our demo. Then you set something called firewall policy. Okay, this is the place where you will define what rules you are going to keep. Again, what rules in the sense I'll show you in the portal, then you will get a better understanding in a while. But just remember, you create something called rules. Once the rules are, maybe we'll just set, we'll put some name, right? Just to keep, I'll just do this. You have to select on which network you want to deploy this firewall. Okay, and we don't need this. Okay, this is just saying like enable firewall manager Nick. So this is something which would be used when you have like huge number of servers which has to be managed, etc. and all. But for our case, we don't need it. And as soon as I select this network, right, it says firewall subnet is already associated to a Azure firewall, which means for one virtual network, you can have only one Azure firewall configured. Okay, the which I already have it. That's why it's telling this subnet is already used. Okay, if you remember, I told you when we want to deploy a firewall, you need to have this default subnet which comes with this name, Azure Firewall Subnet. Okay, this name you cannot change. It will automatically detect, and that's why it is telling, okay, this is already in use. After that, you should have a separate public IP which would be associated. For example, if I have to show you for the firewall which I have already created, right? Let's go and check there. There will be a public IP which will be mapped to that firewall. If I go here, this is the public IP which is mapped to our firewall. Okay, 2041.248.198. That is what you define here. And after that, nothing. Like it's just one tab and then tags create. This once you create this, you will get this resource. Okay. Now in this, if you see, you have policy, which I told you, no, this will be having a policy which is mapped. Now, if I go into this policy, this is where you set all the rules. Okay. So we're going to see these rules, DNAT, network rules, application rules. Okay. So anyone knows what is this DNAT? This is something which I told when we were talking about the network introduction. Anyone
Yeah,
remembers what is DNAT?
destination
Yeah, destination
network
network
address
address translation,
transmission.
right?
Yep, yep.
So what it does is, right, just to quick overview. So if you have a network, okay, let's say you have a network something like this. I'll just say network, and in this case, I'll just keep it simple. Okay, let's say this is a VM, and you have this VM has a public IP, and let's say it has to talk to internet. Okay, this or instead of public IP, let's do it like this. We'll keep this as a NAT gateway. Okay, your NAT will have a public IP, right? I'll just say NAT. Now, what will happen is this NAT gateway can be attached to other VM also. Okay, I can have another VM here. If these VMs has to talk to internet, it will go via NAT gateway and then it will go through internet. If any request is coming to internet, it will be just with the public IP of this NAT gateway. Okay, which means NAT, in this case, NAT is doing something called SNAT, which is like source NATing. So it's going to hide your source or the sender's IP address to the internet. It will be just the one IP. Your public IP is not going to go, and NAT is going to take care of it. Similarly, let's do it in the reverse way. So you have a public IP, which is in this case, Azure Firewall has a public IP. I'll just name public IP. So Azure Firewall has a functionality. Okay, what you can do is if someone is trying to hit this firewall IP, let's say if I have a DNAT rule, okay, what I can say is in the rule I can write. So take this Azure Firewall public IP, translate this IP into some local IP, okay, something like this, and I can define on what port I have to do this. Okay, I can also say it will be like you will also define a port here, something like I can say, for example, 5000. If I hit the Azure Firewall IP with 5000 port, this firewall is going to take that request, and with that rule, will whatever we set, okay, this is going to translate that request to your internal resource. Okay, so in this case, let's say this VM is not having any public IP, and this firewall IP is going to come here and translate it. That is what we call a DNAT. So your destination address would not be like known. It's like reverse of NAT basically. Okay, this is something firewall will give. And other thing is, if I go back to this diagram, right? If there is a internet connection, I told by default, if this VM is not having any public IP, it's going to take the default IP which comes with the Azure, right? But what you can do is you can route this traffic, okay? If this VM, let's say it has to go to internet, right? You can basically route this traffic through firewall and then go to internet. Okay, that's like too much of thickness, probably. I'll reduce it. So you can go to firewall and via firewall you can hit the internet. This is something possible. So these scenarios we will see how we can implement. Okay. So for that, first, what I will do is we need something called route table. Okay. Let's go and search for route tables because to do this right, there should be someone who is sitting and telling, okay, if there is a traffic to internet, you go to firewall and firewall will then transfer it. Okay, that is what we are going to tell. For now, this is one of the spoke VM which I have connected via Bastion. What I will do is let me open command prompt. It will be little bit slow because I'm over the bastion. There is no public IP which I've given. Okay. So what I will do, I'll do curl ifconfig.me. So it's giving some random public IP. This we don't have any public IP with this what with any public IP which we have created. Okay. Similarly, this is spoke to machine. Here also let me open command prompt. I'll show you like what IP we see here, and I can paste the same. So here it's giving some random IP. Now, what we are going to do is, um, before even touching the, okay, let's do this thing. We'll do the route table one, then we'll go to the DNAT rules. So what I'm going to do is, I'm going to create a route table. This will be on spoke one, okay? And let's say spoke one RT, which is just a route table. And this one, let's say propagate this. This you will use it for VPN related things, which we will talk about this later if you want to route traffic via on-prem routes and all. But I can say no also, that's fine. And this I'll keep it in South India. Whatever deployments we are doing today, everything is in just South India. But though it can be on different regions as well, it doesn't matter because we have a peering. Let's create this route table and deployment is started. Similarly, I'm going to have one more route table. This will be on spoke to. Okay, spoke to RT, and let this be no, and we will create this one as well. Once this is done, we are going to define the routes and we'll instruct, okay, if any traffic is going to internet, you go via firewall. Okay, so what we will do, go to routes and let's say add, I'll say like allow internet via firewall. Okay, now we have to tell what is the destination. Okay, in our case, so internet, if you're accessing, you will not know what is the IP, right? Any address which is not in your private, everything is over internet. That's why I have mentioned it like this 0.0.0/0. Okay. And before even applying those routes, right? Let me also show you one thing. Wait, let this come. Continue. Okay, let's close all these things. Right now, internet is working. Okay, I'm able to do this normal search and all, which I just want to show you because things will be different as soon as we play with that route table and all. But why is it slow? Okay, this is still not the home page, but anyways, I just want to show you, okay, internet is working right now in the server. Similarly, if I do on spoke to machine also, it should work. Let's do this. What? I'll say google.com. This will work. You see, we are in the browser, okay, which means internet is working. Now going back here, now we are telling uh, this route table, if I get any traffic to internet, okay, your next hop, okay, should be to a virtual appliance. In this case, our virtual appliance is a firewall. Okay, what I have to give here is the next hop IP address. My firewall will have a IP address, which is like you will have a private IP address, which is also allocated for our firewall, which is something you can go here and take it. Let's copy that IP. This is our firewall IP. Okay, let's put this here. Now we have mentioned this is going to be our root. Now let's go back. Okay, and go to this command prompt. Now nothing has changed, okay, because we have just told the route, but this route table is not associated with any of the subnet. Okay, what I'm going to do is let's do let's pick our VNet. Okay, and this is the subnet I have. I'll click on OK. Done. Now we had another route table also which was created, right? I'll do the same changes there as well. Let's go to the route. We'll add it. I'll say spoke to RT. Destination is an IP address which we copied. And wait, this will be internet address, right? I'll say 0.0.0. Next hop would be the virtual appliance, and I'll give the IP address of our firewall. Okay, done. Then map this route table to the spoke to subnet. Okay, for this changes to take effect. Now, if you see, our connection itself is closed. Okay, I think this connection also would get closed if I'm not wrong, because we have attached this route table, and you will see, like once this route is effect, you will get to know. Now you might be thinking like how we are going to test it. Let's try one more time. Okay, I'll show you. Let's go to spoke one and Bastion. This is how your window looks like. Let me give the username and the password. Let's see if this still works. If not, we have to go for a different approach. Okay, it's applying those settings. Okay, now similarly, or let's see right now if we are able to talk to internet. Okay, this is what I wanted to show. Okay, so this machine ideally it shouldn't have, I mean, rebooted or closed our session, but that's fine. Now this is a spoke to VM, okay, which you can see. Now, as soon as we applied that rule, right? If I do if config.me, it says action deny, reason no rule matched, proceeding with the default action, which means firewall, as soon as I attach it, by default, the default nature of firewall is it's going to block everything until and unless you go and tell or you allow it, it will block everything. That's why you see here, right? It will not be able to fetch. Now, if I do a refresh, this page also will not load. You see, right? It cannot. Maybe let me close the browser. We'll reopen it. If I say google.com, this should not open, basically. You see, it will not be able to open. Okay, because we have attached firewall and we haven't set any rule. Though we have told route table send all the traffic to firewall, right? But we haven't told from there where it has to go. Okay, I think what we can do is there is a thing called ping path or tracer, if I'm not wrong. Let's see if this works. Tracer. Wait. Trace. I don't know this. Okay, tracer, right? What we can do is I'll say google.com. So from here, you see what is this IP? Okay, as soon as I hit enter, right? Ideally, this is going to tell on what path it's going to reach that site. This IP, whatever you're getting here, it is the IP of our firewall. If I go here, this is the private IP. Okay, but I mean, this has a pool of IP address. That's why you see .5, but that's completely fine. It is basically hitting our firewall. Now, in firewall, we have to do something, okay, for our internet to work. That is what we are going to see from the policy. Let's go to the policy. And I told there are like different rules, right? You know what is DNAT. And application rules are something where you can define what website is going to be allowed. Okay, what I will do is, let's say allow, I'll say Google, I'll just say allow Google. Okay, and this is going to be an application type network. Again, you have to put some priority numbers. Okay, for example, I'll just go with 1500. Okay, and I'll say allow, and this is a default this thing. I'm okay with that, and I'll just say allow internet. We're just giving some name. If my source IP address is this, in our case, what I will do is we will pick the subnet range, or I can also pick the IP address of our VM. Okay, and I think we were using spoke 2. Probably I'll pick the spoke 2 for this rule, and it's going to be HTTP or HTTPS request for our case. And what I will do is I'll go with this. Again, you can go with web categories also, which I'll show you shortly. First, we'll apply this change. But in this case, what I wanted to do is I wanted to reach google.com. Okay. And that's the main domain. If I want to access anything, right, I'll put a star and I'll say google.com. Okay. Similarly, we'll add for spoke 2 as well. Let's take this, I mean, spoke 1. Let's take this IP and mention it here. I'll say spoke 1 and this is spoke 2. Then here also I'm going to define HTTP, HTTPS. Okay. Let's add this rule. The problem is with the firewall, right? Each of this rule addition itself is going to take good amount of time. While this is going on, what I'm going to do is we will also set up the DNAT rules. Okay. Now we'll add I'll say RDP for SP1, VM1 like that. And this one, let's say 1000 as a rule number. And I'll say default DNAT rule group. And I'll just say RDP rule. in this case, it's going to be source IP. Okay. And you have destination port, destination firewall IP, and then you have what is that? The translated to IP. Okay. There are like whole bunch of details which we are going to fill. In our case, I'll say source can be any because I just want to try it from my end. And protocol will be TCP. Okay. And I'm going to tell what is the destination port. And this port is something you can give any number because it's going to do the port mapping. If you go back to this diagram, right here, this is what this port, whatever I mentioned here, right? This is that 5000. I'm just putting 3000. Okay. If I'm hitting a request, okay, from any source to the destination, uh, in this case, the destination would be our firewall public IP. Okay. Let me go and take this public IP and I'll copy this, go to this rule. If I'm getting a request of this sort, then translate it to here. I'll be giving the private IP of my VM. Okay, it could be spoke 1 or spoke 2. Since we have the virtual networks which are paired, I can just give that. Now I'll copy this spoke 1 IP and I'll put it here. This has to be translated to port RDP port. Anyone knows what on what port RDP happens? Remote desktop connection happens. Anyone wants to guess? It should be 3389. I'll show it to you here also. If you go to the network settings and you see here, right, 3389. This is the RDP port which I have allowed in the NSG level, but this is how the rule is going to look like. Similarly, I can also add RDP rule for the spoke to as well. I'll say TCP for spoke to, I'll give 4000 and the destination IP is going to be same. And this IP is going to differ. I think I gave 20.1. Let me just reconfirm. Virtual machine. Yeah, 20.1.5, right? Let's go here. Yeah, it is correct. And 3389. Okay, this is how I'll just say SP2, SP1, TP for SP. I'll just name it like this, generic. Okay, this is for the DNAT rule which we are adding. Okay, I'll hit on OK. And again, this is going to take some time. I think our application rules got effect. Okay, now this is in place. Now what I will do, I'll go to Spoke 1 and here also. Now if you see, Google is working. Okay, but if I type facebook.com, this is not going to work because in firewall we have allowed only google.com. Any domain with Google, probably I'll say drive.google.com, this will also work because we have allowed any child websites which is with accounts.google or drive.google or mail.google, like that. Google have multiple sites, right? So all these things will work, but anything apart from that is not going to work. If I do bing.com, this will not work because we haven't allowed these things from the firewall perspective. Only this website is what we have allowed. Okay, that is how you can set application rules. But I told you there are like categories also which are available, right? So if you go to web categories, right, here you can find, let's say you have a set of websites which you wanted to block. Let's say, let's take linkedin.com, right? If I search, you will get to know on what, okay, there is a typo. Okay, on what type of category this website is. Okay, instead of giving a specific URL, you can also have a rule. If I have to show you here, based on web categories, right? So you can select what kind of websites are allowed in the network. For example, I can just say like there is a category called computer and technology. I can just allow only websites which are in this category to be allowed from this network. Any other things which is not in this will be blocked. Something like that. Like Azure has classified a set of network websites, and you can also use this option. But mostly, like if at all, if someone is configuring, they'll go with this option and they'll just allow access to those websites only. Okay, so that is how you can use application rules to restrict internet and give more secure. If you remember when we talked about NAT gateway and all, right? I told you like though it is giving a secure internet connection, still someone can download a code or a malicious software from a website which they shouldn't, and that can break your system, right? That is where like this firewall is going to help. You will have more control on what is allowed and what is not allowed. Okay, so this is on the application rules side. Any questions so far? No? Okay, awesome. I think
No.
no, right? Okay, fine. The DNAT rule is also in place now. I'll show you like how this is going to work. Let's take this IP. What I will do is STSC, and I think like this we can give, if I'm not wrong. You see, right? I gave port 3000. Okay, if I have to show you again, I'm giving port 3000. Okay, and port 3000 is something we have given for SP1. Let's see if we are able to connect. See, with the firewall IP, with this custom port, obviously no one would be knowing, right? What port is this, right? So from this port, I'm able to take remote desktop. Similarly, what I can do is I can also do and give port 4000, and this is going to work. You see, right now with the firewall IP, we are able to take a remote desktop connection with this DNAT rules. Okay, so that's the usage of DNAT. Now the only thing which is pending is network rules, which again we'll see it in action only, right? So network rules is something which you can use to tell, and probably you can establish the connection between the network. Okay, in our case, these two are networks. Probably I'll use this one. This would be, where is that? Maybe I closed it. Anyways, so there is no peering between these two networks, right? There is no peering. But what I can do is, if spoke one wants to talk to spoke to, right? This can send the request to firewall. Firewall will send the traffic again to spoke to. Okay, let's see that. Allow internal connection. Okay, I'm just naming it randomly. I'll just say 1400, and this would be default network rule. This is SP1 to SP2. Okay, I'll say if my source is this, and let me go here. I'll go to virtual machine. I'll pick this IP. SP1 is this, right? Which is the source. Protocol is TCP. I will also enable ICMP. Okay, and anyone knows what is ICMP? is this protocol used for?
To ping the meters or IP address.
Right, right. So by default, especially on cloud, you will not be able to ping the VMs, right? Just because you are not able to ping doesn't mean the VM is not reachable. They'll basically open a specific port, so you can do telnet or testnet connection to check the accessibility. Okay, but in this case, let's enable this as well. Destination is going to be what I will do is 3389. Okay, and destination type is again an IP address. In our case, okay, I actually spoke one should be here, which I gave correct, right? Okay, spoke 2 IP is here. Similarly, let's do reverse also. Spoke 2 to spoke 1. Now here I'll give spoke 2 IP address and ICMP. I'll give 3318 because this is something easily we can test. That's why I'm giving that port. Okay, so we have set this rules, okay, and let me click on add. So we just have to wait for 2-3 minutes for this rule to get applied, okay, then only we'll be able to test it. So this was one thing which I wanted to show. While this is going on, maybe what I think we'll see is, so this firewall has, okay, maybe what we will do, I'll open this firewall. Mm, okay, let's go to the policy only. We have seen all these rules and what is their usage. Again, like there are other settings as well. This gives you threat intelligence if you want to whitelist anything, or if you want additional threat intelligence and all, like they provide. Okay, here by default it is alert only, but you can alert and deny also. Like if any unauthorized person is trying to access your network and all these things will come into picture. Then you have TLS inspection and all. Like most of the things are like with the what I can say, with premium features you get whole bunch of things. While this is loading, what we will do is Azure Firewall SKU. We will quickly see. So if you go here, right? I think if with premium, you get like a lot of other things like inbound TLS termination, outbound TLS, all these things you get, but most of the things are covered in the standard edition itself. Okay. But one key thing is, let's say if you attach a standard edition firewall, right? Your network bandwidth which they provide is 1 Gbps. If you have a larger network, right, this could be a problem. Okay. In that case, premium is giving you 10 Gbps. If you are more from the networking background, you'll be able to relate it. Especially if you are dealing with larger networks and all, this will be a problem. Okay. So this is on the SKU. We'll just wait for a few more minutes. This should be done so that we'll be able to see. Okay, right now we don't have any peering between these two networks. Okay, if I go to network, which I already showed you, but just to reconfirm, right? There is no peering here also, but we will spoke one and spoke two should be able to talk after this rule implementation. Probably what we will do is, while that is going on, I'll go to command prompt. Let me see if it is working now before even, because sometimes okay, this is done now. For sure we know it is done. Let's do config. This is spoke one. Okay, 10.10.1.5. What I will do is I'll do mstsc and let's give 20. Let's see if this is working. This is still not working. Let's do one thing. Okay, we'll take this IP I'll show you one more thing. Okay, we have something called network watcher. Okay, which should be here. So this network watcher is something using this you would be able to troubleshoot network related things and all. Like, let's go here. For example, okay, let's say in our case, we are troubleshooting this and my destination IP is this one. Okay. So there are different things which you can troubleshoot. I'm just choosing this next hop. Okay. So what I wanted to show is we are sending a request from spoke VM1. Okay. And it is going via this network interface. And this is the source IP and this is my destination IP. So if you see, it says my next hop is to the virtual appliance, which is our firewall. This is perfectly fine. And it is telling this is happening because of spoke 1 route table. Now let's reverse this. Okay. I want to do it from spoke 2. And all these things are getting automatically populated. I'm not entering. And let's do this. And let's select next hop. Now, if this is also hitting to virtual appliance, then our configuration is correct. Okay. Let's just wait for this. Okay. This is perfect. Now, Uh, the other thing which could play a role is let's go to the networking. And if I go to the pairing section, right, we have something called, okay, this one, right? It says, if you read this, right, it says allow spoke one VNet to receive forwarded traffic from hub. Okay, what this says is if there is any traffic which is coming from spoke one to firewall, you take this traffic and do the forwarding to whatever is the address. Okay. So this is something which has to be enabled for to work. Wait, I don't see save option here. Wait, let's go here. Pairing hub to spoke. For some reason, wait, let me refresh this page once. And let's see, it's not giving me this option. Wait, refresh. What I can do is, if this is not happening, we will remove the pairing only. And okay, let's do one thing. Let's go and remove the pairing and we will add it again. And type delete. Okay. So once this pairing is removed, right, we'll recreate anyways. Nothing else should break ideally. The Bastion connection would break, and this firewall will also not work. But that's fine. We will re-establish it. So now we are going to add this pairing again. What I will do is, okay, let's say this is going to be spoke 1 to hub. Okay, let's select spoke 1 VM and let's enable this. And this will be hub to spoke 1. We will enable this as well. Once this is done, similarly, we will add other pairing also to for spoke 2. Okay, then only because we need it on both the end to test it. This won't take much time. Okay, I know we crossed 12, but just few more minutes. I'll say spoke to hub, and let's select spoke to. We'll select this, and here I'll just say hub to spoke to and enable this. Okay, I think we are good. Fine. This should complete. We'll just wait. It will just take few more seconds. While that is going on, let's open command prompt. Okay, I think this is also done. Now let's try this. You see, right? We are getting this prompt to enter the credentials, which means this VM is accessible. So if you see, I'm giving, we are in spoke 1, okay, just to show you 10.10.1.5, and from here we are able to reach to 10.20.1.5. Okay, this is without any pairing between spoke 1 and spoke 2. Similarly, if I go here, let's take MSTSC and 10.10.1.5 is the spoke 1 IP. If I have to show you here also, this is 10.20 and we are able to reach. If I'm getting this prompt, obviously, if I give username and password, it's going to work. Okay, so this is about firewall. I think it's like a lot of things, but I'll stop the recording for now and